I'm giving you theory, we'll do more problems tomorrow. So when we want to express our complex number in polar form, so we have three representation how we can express our polar form. We can express it as a complex number z, which is equals to r into cos theta is it plus j sine theta. So that's how we express our polar form, our complex number in polar form. So we can even express it as RCIS theta. So normally I say it's R cosine in sine theta, the complex number. And therefore Z again equals to, you can express it as R. Therefore our argument theta then. So R our argument theta. So you can express your complex number in that way. So using a previous example that we applied in polar form, so Z is equals to, so the complex number that we had in the previous one, it was 5 plus 2j. So we need to convert this into polar form. How will we convert this into polar form? First of all, we need to find R, we need to find augment theta. In previous example, we did find theta, but you can repeat it again if we're not plotting. So finding our augment theta, which will be equals to arctan V over A. So they are both positive, so we can just plug it in as it is, 2 over 5. So we said the solution is equals to 21.80 degrees. Then R is equals to, we'll have square root of B, it must be B squared, or let me write the whole formula, B squared plus A squared, which is equals to, B is the coefficient of J, which is 2 plus and 5 all squared. And this gives us our modulus R. We have 4 plus 25, which is 29. Is it root 29? So you can leave it as root 29, or you can leave it in decimals if you are asked to leave it in decimals. So now we can express our complex number in polar form. We can use any of the three representations, but normally we are used to root 29 augment theta there, which is 21.80 degrees. 21.80 degrees. We have expressed our polar form, our complex number in polar form.